In today's class we will try to solve some problem based on capacitors and also their combination, series and parallel. First take down this problem. Figure shows two identical capacitors C1 and C2 C1 and C2. Figure shows two identical capacitors C1 and C2, each of 2 microfarad capacitance. 2 microfarad. Each of 2 microfarad capacitance. Connected to a battery of 5 volt. Initially switch S is closed. Initially switch S is closed. After some time S is left open. After some time S is left open and dielectric slabs of dielectric constant K equal to 5 and dielectric slabs of dielectric constant K equal to 5 are inserted to fill completely the space between the plates of 2 capacitors. How will the charge question number A, how will the charge and potential difference between the plates of the capacitors are be affected after the slabs are inserted. Figure shows two identical capacitors C1 and C2, each of 2 microfarad capacitance, connected to a battery of 5 volt. Initially switch S is closed. After some time S is left open and dielectric slabs of dielectric constant K equal to 5 are inserted to fill completely the space between the plates of the 2 capacitors. How will the charge and the potential difference between the plates of the capacitors be affected after the slabs are inserted? Let me give you the figure. 5 volt battery we have, and then we have 2 capacitors identical. This is C1 and we have a battery switch over here. Through the switch we are connecting another capacitor C2. 5 volt battery, and this is the switch S, C1, C2. Volt battery, C1, C2 and S, and the value of C1 and C2 are given 2 microfarad. 2 microfarad, C2 is also 2 microfarad. Both are identical. 2 microfarad, 2 microfarad. Now, let me give you a note to tell you like what happens when we insert a dielectric slab, and also when we connect and disconnect the battery. Remember this note. Note. When a dielectric medium of dielectric constant K is introduced, when a dielectric medium of dielectric constant K is introduced, in an isolated or not connected with battery, in an isolated capacitor, in an isolated capacitor. Isolated means here the meaning is not connected with the battery. When a dielectric medium of dielectric constant K is introduced in an isolated capacitor, then total charge on capacitor remains same. Remains the same. And when in a capacitor connected with battery, the potential difference across the capacitor remains as that of the potential difference across the battery. In a capacitor connected with battery, the potential difference across the capacitor remains same as that of the potential difference across the battery, as that of the battery potential. So in a capacitor connected with battery, the potential difference across the capacitor remains same as that of the battery potential. Now first the switch is closed. So when a switch is closed, so in the question it says initially the switch is closed. So when switch is closed, we will find out what is the charge stored in each capacitor when switch is closed. So first draw the circuit with switch closed. So this is our 5 volt, and then we have 2 capacitors connected. So I am closing the switch. Switch closed, the two capacitors are connected in parallel across the battery. So when this is the case, now when the switch is closed, two capacitors get fully charged. Charged with 5-volt battery. Two capacitors get fully charged. So charge on capacitors are given by charge on capacitor C1 is Q1 equal to C1 into V. C1 into V. So C1 is 2 microfarad. 2 into 10 to the power minus 6 multiplied by 5. 2 into 10 to the power minus 6 multiplied by 5. So this is 10 microcoulomb. 10 microcoulomb. 10 microcoulomb. Similarly, the charge on capacitor C2 is Q2 equal to C2 into V. Here value of C2 is and V are same because they are identical capacitor. So you don't have to calculate twice. You can write they are same. So 2 into 10 to the power minus 6. So again the charge on each capacitor is 10 microcoulomb. So this is equal to again 10 microcoulomb. Now this is the first case. Now we are opening this. We are inserting a dielectric medium and also the switch is opened. So after some time we are opening the switch and we are introducing a dielectric. So you can write here after opening S, opening this switch S and inserting the dielectric medium. After opening the switch S and inserting the dielectric medium, for C1, first we will calculate for C1. So now C1 is connected to the battery. So if you draw the diagram with this, so C1 is connected to the battery itself, whereas C2 is not connected to the battery. You can take this as C1 dash C2 dash because this is with the introduction of dielectric. For C1, it is connected to the battery, so the capacitance of C1 is K into C1 is, I can write it as the capacitance of C1 as C1 dash, which is equal to K into C1. So K is 5 into 2 microcoulomb, that is 5 into 2 microfarad, so it is 10 microfarad. Now voltage across C1 dash is 5 volt itself. Voltage across C1 is 5 volt itself because it is connected to the battery. Now charge Q is equal to C1 dash into V dash. C1 dash into new V, C1 dash into V. So which is equal to 10 into 5 into 10 to the power minus 6 is there. So it is 50 microcoulomb. Similarly, you can write for C2. For C2, new value of capacitance is K into C2, which is equal to Ks2 into 5 equal to 10 microcoulomb. Sorry, microfarad. Similarly, the charge we said in the note that the total charge remains same. So charge Q is same. Charge Q is, it remains the same. So what was the charge before? It was 10 microcoulomb. Voltage is V is equal to, we know Q is equal to CV, so voltage is equal to Q by C. Q divided by C, which is equal to 10 micro divided by 10 and equal to 1 volt. This is how we have to calculate.